Hi, Lucas. Welcome to BizTalk. It's my great pleasure having you with me today. How are you?
Good morning or good afternoon. Thank you. Thanks a lot for the invitation. Very pleased to be here.
The pleasure is mine. I'm very excited to talk about Manta Aircraft. It's unbelievably just look beautiful. Let's see how the technology, what is about. But before, let's talk about yourself, a little bit your background, please.
Sure. Well, I was born as an aeronautical engineer, and I worked in aerospace, and then I moved to motorsport, Formula One, Formula Indy, everything that was running fast with an engine in the back. I was having fun there for some years, and then I switched to management, always staying in the technology field, so different technology sectors. And lately, it happened 2 years ago, a bit more than 2 years ago, that we met with some friends, all coming from aeronautics and motorsport, and we had the idea to start something in the advanced air mobility. At that time, it was called the urban air mobility, and we wanted to create something a bit different. And so we started with a different approach, with a different concept, and this is the evolution of what we had in mind. So today we are really coming to the point of seeing the idea to materialize and hit the runway of an airport quite soon. So we are pushing a lot. We are going fast, and I'm very pleased to share this idea.
Thank you, Lucas. And I don't want to wait and waste even 1 second, so we can start talking about Manta Aircraft.
Thanks. So yes, as I was saying, we started from the idea of creating a vehicle for the advanced air mobility. And the advanced air mobility, as you know, it's a new sector. It's new aviation. The world is changing very fast, and it's bringing the possibility to the people of flying these vehicles or these aircraft that we all have in the back of our mind, because we all have seen the movies of Star Wars, of Fifth Element, of Blade Runner, all these movies where it's possible to start with your own vehicle from the back garden and fly to another place which is right in front of the house of your friend, or go downtown, or go to the seaside and land just close to your place. So this is becoming a reality. It's very quickly becoming a reality. And this is Manta Aircraft. Manta Aircraft is developing a platform. So we are developing a concept of vehicles like the one that you see on the screen. It's a concept of an aircraft with certain peculiarities that we'll go through now in the presentation. So as you might have noticed, the advanced air mobility sector is growing really, really fast. It's enough to say that there are some players which are now valued some billions. Everybody thinks that now this is the sector that can take advantage of the technology that there is around, and put it together and create something really new. Bring the possibility to fly with this type of vehicle to everyone. So everyone means maybe you will be a passenger. You can fly with this in 3 years, 2 years time, 3 years time. You can jump on this and then take off vertically and then land somewhere else very close to your final destination. So the market will be huge. Every sector analysis says that it's going to grow a lot, and every month that goes by, the sector dimension is estimated to be bigger and bigger. Why? Because it's because there are more and more missions that can be found to be used, to be appropriate for these type of vehicles. So these vehicles will be able to do more and more things. The more we develop them, the more we understand how to use them and how practical they can be. So there are around in the world, there are more than 200 startups. We will see which is the peculiarity of the Manta proposal compared to the others. So the market is growing very fast. This is there are so many reports saying this, and also quite important people or famous people from aviation are entering this sector. It's enough to say that Muhlenberg, it's the ex-CEO of Boeing, has created a SPAC to acquire a eVTOL company at the beginning of the year. Tom Enders is now the chairman of the board of directors of Lilium. And Giuseppe Orsi, who was the CEO of Augusta Westland first, which is now most likely the biggest helicopter company in the world. And then he was the CEO of the now called Leonardo, which is the Italian group for aviation. He has been caught by Manta, and he has joined Manta. So what is the design point of Manta? From the beginning, what we decided was to set a certain mission for this vehicle. And the mission is fly at least, let's say 300 kilometers, better 400 kilometers range at a speed of 300 kilometers per hour. So this is the target that we have set at the beginning of the design. So comparing the missions of the other players, Manta has a different mission. So it's not better, it's not worse. It's a completely different mission. At least it's completely different. It means it's obviously this range and this speed have implications on the technical solutions that we have adopted. So the solution we have chosen, which is a hybrid propulsion solution, not battery only solution. It's the aircraft is propelled by a gas turbine coupled with a generator, coupled with batteries. And the current coming from these systems is used to power 8 electric motors that are in the fuselage and under the wings. With this configuration, the aircraft has a very wide range of operation because it can take off vertically and land vertically, but it can also take off as a normal airplane, increasing a lot the payload. So this means increasing the payload means also increasing a lot the fuel that it can take. And this means expanding a lot the flight envelope or the mission envelope of the aircraft. And this in this graph, it's illustrated. So the aircraft is aimed at fulfilling some missions that today are done by helicopters. The aircraft is not meant to replace the helicopters. The Manta vehicles cannot hover. They are not designed to stay hovering. The helicopter can stay hovering as long as it likes. Manta vehicles are made to take off and land vertically like a helicopter, but then fly like an airplane. So it means that they can be used for missions of law enforcement, where you need to check, to perform checks and controls, infrastructure surveillance, offshore transportation, cargo delivery, and so on. And this is a typical operation, let's say, of the aircraft, because it combines the capability of taking off vertically and then fly fast and far away. And in the case of personal transportation, it can be used also if you want, as I was saying at the beginning, you want to fly from one place and land in whatever other place. It's good. You can use it instead of a turboprop today, or you can use it instead of light helicopters, or like for leisure flight, or if you want to set up a service of a limo service, then this is the type of aircraft that might work. We are developing also the 4-seater, so this is more appropriate for this type of service. Or you can use it, for example, for missions like surveying and imaging and terrain mapping. So this is this is the panorama, okay, the landscape of the other players, some of the other most famous players. And compared to them, the Manta platform has a different design. Why? Because as we said, the mission is different. So we are targeting a different market. We are not interested in the urban air mobility only, but we are targeting the regional and inter-regional mobility. Compared to other initiatives, let's see where we are positioned in terms of status now, or stage of development of the project. So we have already a technology demonstrator. It has flown in December 2020. It's a 1/3 scale model, and it has hovered. It still hasn't. It didn't do the conversion from hovering to horizontal flight. That's something that we have been studying in the simulator, and before doing the real test, we do a lot of simulation and simulator hours. So the whole development is based on simulation and computer aided design. And what is the market? You might wonder what's the market. It's not just maybe police missions or transportation of individuals. Well, the market is quite wide. For this type of aircraft, we have seen that there is an interesting market, especially in the US. For example, this is as you know, it's the biggest aircraft market in the world. And those aircraft which are piston airplanes or turboprop airplanes, sometimes or very often, they do missions that they can take over, that can be taken over by the Manta platform. So this is the Manta proposal at the end. Something that fulfills your wish or your need to move and fly by 200 or 300 kilometers or more, depending on the amount of fuel that you want to put on board. So these are some use cases. You can use it to go to the seaside, to the beach house, or it's also designed to be capable of taking off and landing from yachts, and landing also on close to your place. Interiors are at the level that is expected for an aircraft which is going to be used for private flights. And there are already ideas about creating the vertiports for this type of aircraft. See. But it's, as we mentioned before, it can be used for rapid intervention in case of disaster, in case of medical emergency. It can be used for patrolling. It can be equipped also with sensors. So we are designing the aircraft with the capability of taking on board different types of sensors, which can be used for terrain mapping, surveillance, and so on. And it can be used also for searching. When somebody is missing, or when there is an emergency and an aircraft that is not so expensive to operate, and go and search for something. And this is an important aspect, the price, the cost, actually, the cost of operation of these aircraft. Because when we are thinking about an aircraft to be used for passenger transport and travel, or we think of a helicopter, or we think of an airplane. Forget about the airplane jets, which are in a different category in this case. But think about the helicopter, which takes off and lands vertically. The helicopter has a quite important cost, an hourly cost, and a total ownership cost, which is very important, which is high. With this aircraft, we are targeting an hourly cost that is between $200 and $300 per hour. This means that the cost compared to a helicopter is about 1/10. And this is a big difference. So also using the aircraft for police missions, for search and rescue, for fire control service, for ambulance, this means that the cost of the service is much lower than with a helicopter. And this is a big push, obviously. So which are the main characteristics of this platform? It's first of all, as we said, it's a hybrid electric propulsion system. So there is a gas turbine behind the pilots. The gas turbine in the future can be replaced by a hydrogen engine, or it can be replaced by batteries. I mean, there is the whole compartment that can be filled in with batteries. Or we can also think at the time being using the gas turbine and using diesel fuel or biodiesel or biojet A1. So it's also suited for using biofuels, which are becoming more and more common, and they will increase their availability in the future days. So it's a full carbon fiber aircraft. It's a fly-by-wire. It has a human-machine interface, which is meant to be very friendly, user-friendly, easier than normal airplanes. And it has the safety of a ballistic parachute, has flaps to land as an airplane, normally as an airplane on a runway at low speeds. And it has the wing tanks for the fuel. They are big wing tanks. So if you want to fly far away, then you can fill the tanks, and we have a lot of fuel that can be stored in the wings. So Manta is developing this platform that can take the shape of a two-seater, of a four-seater, of a cargo. It's quite flexible, but at the basis of this, there are these four pillars, what we call the technology pillars, that we are focused on. The first one is the design, which is registered. Then we have the propulsion system, hybrid propulsion system. We are developing a system which is, let's say, it will be adaptable to also other machines. So it could be installed also on other machines. It means we are creating an asset that it is valuable by itself as well. It does not need to be linked to the rest of the project. So this is also a peculiarity of the Manta approach. Then we have the avionics. So obviously all the flight controls and the flight control laws of the aircraft, they are developed in HiSLab, and they are obviously tuned for these type of vehicles. And then the human-machine interface that is meant to be quite easy, quite user-friendly, so that it will be better for the pilots, which will have the possibility to fly more easily these aircraft, right? So at the end, it's a multi-purpose platform. So it's engineered as a platform with a modular approach, as much as possible modular, so that we can reconfigure it, we can upgrade it. And this is meant to offer a longer life cycle. And the hybrid propulsion system grants a longer endurance and range, no need for electric recharge infrastructure, because this is a big problem. All the vehicles which have only batteries, they need a recharge station and recharge infrastructure. And this type of solution with the hybrid propulsion system does not need a ground infrastructure. You can land close to a fuel station, just fill the tank with diesel, and you can take off, and you don't care about the recharging the batteries. The batteries are automatically recharged by the gas turbine. So there is also no need for stopping the vehicle to recharge the batteries, and there is no high cost of battery replacement. The batteries are smaller, and we have batteries which last many cycles. So these are this is a new type of battery which has this characteristic. And it's also environmentally friendly because we use biodiesel and biojet A1. So also synthetic fuels are coming. So it's not anymore the classical fuels that we are used to use, and they are going to be banned sooner or later, right? And the capability of taking off and landing vertically, it means that it can take on some missions from the helicopter. It can fly fast as an airplane, and it also allows a quite fast time to market, because the configuration of the vehicle is something that is quite known. I mean, we know, and the certification authorities also know this type of configuration. It's a canard. No, the Wright brothers in 1903, they flew with a canard. So this is the first configuration that has ever flown. And so this is also playing in favor of de-risking the project and shortening the time to market, because we think it will, right? It has safety features like the deployable ballistic parachute, energy absorption structure, and the aircraft is full fly-by-wire. So it means that it's controlled by a computer. The pilot gives its inputs, but the aircraft is prepared for the future to be able to fly by itself when it will be allowed to fly with passengers on board in automatic mode. And so you see here the first one, the first aircraft we are developing is the two-seater, but we are already thinking, and we have in the background the four-seater coming. And this is just an overview of a rendering of the four-seater, or the four-seater, the combi, right? So it will be like a combi or a car that you can adapt, and you can decide how better suits your needs and from time to time. Just an idea about the price, because everybody asks as a second question, he always asks, what's the price of this aircraft? And then this is, yeah, that's normal, it's clear. So we think it's the price will be around 1.5 million euros for the two-seater, and the four-seater would be a slightly more expensive. And then for the special missions version, then it depends on the configuration that is requested by the customer. So it will go to 2.5 million. But this is anyway, it's the direct comparison of this price is the helicopter, the equivalent helicopter that can fly at 300 kilometers per hour for 300 kilometers. And if you want to have such a helicopter, you will not spend less than this. Actually, you will spend maybe the double of this or more. So who is behind this project? Because this is another peculiarity of Manta Aircraft. We are a small group. We have decided that we have formed a group with all professionals who have at least 20-25 years of experience. So it's a small group with very skilled professionals. We have some junior engineers. They are now 3 junior engineers, and all the others are very skilled professionals. And this is also, as I was saying, it's a peculiarity of Manta, which allows Manta to be also very fast in developing the whole project. And if you think that we have started at the beginning of 2020, and December 2020, we have made the 1/3 scale model fly, it means that we have already designed the layout of the aircraft by that time. And then we have carried on during 2021. This is an overview, sorry, for the timing of this enterprise. So at the end of 2020, we had the rollout and the first flight of the 1/3 scale model. Mid of 21, we had the design freeze. So we went to the wind tunnel and we verified that the design that we have done is proper and there are no glitches in this. And then we expect to have the rollout of the first real prototype in August, or let's see, end of the next summer in 2022. And then the 4-seater will come. This is a picture of the 1/3 scale model. And here is one of the first flights last year. We went to the wind tunnel. We did the wind tunnel testing. And just a quick note before closing this talk is about what we think for manufacturing. We have identified some suppliers already. We have identified clearly which are the materials that we want to use, what is the tooling, the type of tooling, and so on. And we have identified different technologies that we want to apply in this aircraft. There are some new technologies, but most of everything, we try to stick to what is known and what is proven. So we introduce advancements in the 4 areas that we mentioned, in the design, the hybrid propulsion system, the flight control laws, and the human-machine interface. For the rest, we try to stay on what's already on the shelves and what is already established and verified. So this is to reduce the risk of the project and to try to reduce as much as possible the time to market. So the production strategy is thought to be in modular. So it means that we design the aircraft in modules, and they can be assembled and then all together after coming from the suppliers. So this is a typical automotive approach with a plug and play concept, and also it allows a much easier technology compensation program. So if a country wants to contribute or have its own factory there, they can start creating some modules, and then they can assemble this depending on the technology level that they have. So I think it's quite interesting concept, and on the news we have seen some articles coming out and presenting the aircraft. And well, here are some specs of the aircraft. If anybody is interested, we can go deeper into these numbers. Yeah. So here we have, during the project, we are creating some assets, and we have 3 main milestones from now till the end of next year. And one is in October, right in October now. And at this time, we have created these assets. So it means that they are already a value that is available. And this is also going into the direction of de-risking the program. So at these milestones, we create assets that have an intrinsic value, regardless of being inserted in the whole rest of in the program. In December this year, we will complete the drawings of the aircraft, the propulsion system. We have a test bench ongoing, so it means the development will be ongoing and will be finished beginning of next year. And again, also for human-machine interface, avionics, the simulator will be richer than it is now. And in April next year, we'll have everything completed from the manufacturing point of view for the prototypes. We'll have the hybrid propulsion system test bench completed. The avionics will reach a level which allows us to fly in automatic way the complete mission of the aircraft with the 1/3 scale model, and start to test, right, this programming for the future flight of the 1-to-1 scale. And so the same for the simulation, we'll have a full pilot in the loop simulator. So whoever wants to have a go and try to fly the aircraft, he can sit in the simulator and see what it means to fly this type of aircraft. And the simulators in the future will be used then for training, right? So these are the aspects that and the assets we are generating, and we are waiting for the future to come.
Thanks, Luca. Extremely fascinating. Let's jump into the future, but it's not that far away. Actually, just after tomorrow, let me say. I mean, we have been covering everything, so I don't want to deep on what you already talk about very clearly. Let me ask you, you had 2 business models, okay? One is retailer and one is more related to business and probably even states. Where do you think you can profit the most in the coming years when Malta will be fully operating?
Well, for sure, the biggest market for this type of vehicles is North America. It's in North America. It's in the States, and there are so many aircraft used in the general aviation sector. Just enough to say that in the US there are more than 212,000 general aviation aircraft. So just take away the business jets, and the big helicopters, and you have more than 170,000 aircraft there. And so this is a big market with a sales volume of each year, which is equivalent to between 1 and 1.5% of the whole number of aircraft. So there are many aircraft sold in that market, and that's where we would like to position these platforms, so the 2-seater and the 4-seater. But not only there. Think about countries like Australia, where you have to fly inland. You have to fly for 300 kilometers maybe to reach a place inland. And when you land there, you have no ground infrastructure. So for sure you will have the diesel fuel, because the tractors and the car and the trucks goes with diesel, and you can use the same diesel to fill the tank of the aircraft, and you can land the aircraft there vertically or on a short airfield, and you are totally independent of any other infrastructure or any other ground infrastructure. And so these type of countries can benefit from this mobility or air mobility that is coming. So we are targeting also these countries. US, there are quite interesting distances to cover. Australia, Africa, and Europe, obviously, because if you want to fly from Paris to The Hague, well, you can do it with this. I mean, it's also quite fast. So it's clearly a place, Europe, where there is a ground infrastructure transportation network, let's say, which is very well developed. So the advantages of these type of vehicles are bigger in countries where there is less ground transportation infrastructure. But this doesn't mean that in Europe, if you want to fly from one city to another city quickly and land very close to the city center, then you can use this aircraft, and it can be much faster than taking a train or driving by car, or taking a normal commercial flight that takes you to the airport, and then from the airport you have to go downtown. So it's much longer, right? So the biggest market that we see is for sure US, but also the rest of these countries.
Yeah. Manta is eco-friendly because it's eco-fuel, battery. But when I compare Manta to helicopters, what comes to me is noisy. Helicopter is absolutely, has such a hell of a noisy. And for when you live in an airport, you have an helicopter close to you, it takes off, it's a nightmare. What about noisy when it comes to Manta, as maybe you can also land on top of a building, right?
Yes. Well, in a helicopter, 70% of the noise comes from the rotor. 70%. The rest, the other 30% comes from the turbine. So it's all from the combustion engine. So in this case, we have no rotors. We have ducted fans. Ducted fans are meant to be quieter than open rotors. And obviously we have the turbine, but we can exploit also the batteries. So we can reduce the use of the gas turbine and use more batteries. So in terms of noise, we are now conducting a study to simulate the noise, understand what's the impact of the noise generated by this type of concept and platform. But for sure, it's more advantageous compared to the helicopter. We haven't got the big rotor. We haven't got that big part of noise that comes from the rotor. And it's not only the intensity of the noise, so not only the noise level, but it's also the frequency, which is important in the feeling that we get when we hear a noise. So the frequencies here are different, and we are studying the topic to optimize the frequencies and understand how every frequency content is present in the noise generated by the aircraft, and how well accepted it can be by the people who see and hear these type of vehicles flying by.
When it comes to business model, you're going to sell Manta aircraft, you're going to lease, I suppose, but also you have the platform model. So are you going to provide your platform to other competitors?
Yes, the idea we have is to create these modules, which are the technology modules that I mentioned, and make them available also to other manufacturers. So if somebody wants to create a vehicle with a different shape, with a different mission, but he needs a hybrid propulsion system, well, okay, we can provide it. That's our idea. We can offer it. If somebody wants the whole mathematics for controlling the vehicle, maybe we can use our mathematics, which we are designing in the most flexible way, to also to offer to somebody else. And the same way for the human-machine interface. So this is the modular approach that we have taken, which leads us to be in a position of offering these modules to the other manufacturers. So we want to share this and offer this to others, yes. And not only offer the vehicle, the complete vehicle.
I mean, Malta is quite light when it comes to infrastructure. Do you think that's a very good advantage point for you? Because infrastructure is a big deal, for example, in any kind of mobility.
Well, absolutely. That's why I was mentioning the case, for example, of Australia, that you want to fly to a farm which is 300 kilometers inland. There is no infrastructure maybe there. Okay, you can do it. Or you have to land for an emergency because you are a doctor and you have to be taken somewhere, or you need to intervene because you are a policeman, and you can land almost everywhere with this, and you don't need the recharging, the battery recharging station, and you don't need anything on the ground apart from the fuel. And anyway, the endurance of the aircraft is quite long, so you can perform quite long missions. So let's not forget that Tesla had a very, very hard time selling cars until it invested a lot of money into the recharging infrastructure. So without the infrastructure, the battery-only vehicles have a hard time. It will come, the infrastructure will come, sure, but we do not want to be bound to an infrastructure that we cannot control, that is not depending on us. So we want to be able to go to the market without the need for somebody else to create an infrastructure.
I mean, that's a capital intensive business. Are you on the fundraising, and how much do you think you need in the coming years to develop and having Malta fully operating and start selling the product to the market?
Well, we have the project, the program actually is divided in two phases. One phase is until the end of 2022, beginning 2023, which is the first phase when we create 2 prototypes and demonstrators. And for this phase, we are raising 20 million euros. And then it comes the other phase, which is the next phase for certification. We have already started talking with the certification authorities because certification is something that you have to face from the very beginning of the project. So we are already talking to them, but the real heavy work will come in 2023 once we have the prototypes. At that point, we will need at least 1.5 to 2 years to certify the aircraft. And this phase and also the preparation for the production will take about the same amount of money that we need for the first phase. So the advantage of this type of aircraft is also that since we are not targeting air taxi, we can also offer the aircraft as an experimental. And in the US, you can fly experimental aircraft without having a certification, but you cannot offer a public service with an experimental aircraft. So this is one of the, let's say, the strategies that we have put in place to shorten the time to market. Sell the aircraft as an experimental first, and also since this is is born as a private flight vehicle, air vehicle, and then it does not need the certification level, which is the enhanced category. We can certify this in the basic category, and the basic category is much simpler than the enhanced category. But if you want to offer a public transportation service, then you have to have the vehicle certified in the enhanced category. That is more complex, it takes longer. So again, we have chosen a route to have a shortened time to market. Right.
I mean, I'm very curious. What's your vision for Manta for the next 5, maybe even 10 years time?
Well, it's what we want to be is a developer of this platform and take the aircraft on one side, take this platform and create different types of aircraft, right? A two-seater, a four-seater, a cargo, and so on. And on the other side, we would like to be able to offer other manufacturers components and subsystems that they can take as a ready-to-go subsystem to integrate into their vehicle and speed up their process. So we have these two phases, and I think both of them can be very rewarding.
Lucas, thank you very much for coming to BizTalk. It's been a very great pleasure having you with me today, and I do love what you're doing, and I'm pretty confident that you're going to be a very great success.
Thanks a lot, Max. It's a pleasure being your guest.
Pleasure's mine. Thank you and good luck.